All right, in this video, we are going to talk about interfaces in Java. So at this point, we have already talked about inheritance in classes, right? And so some languages will allow multiple inheritance, but Java for classes only allows single inheritance, right? So we talked about how every Java class, except for one, has exactly one parent class. Okay. So if you try to, when you use the extends keyword to make a child class, if you try to list two parents there, it will not be able to do that. The reason why is because there can become some nasty problems with inheritance, like basically conflicts between fields and classes, and it becomes impossible to resolve that situation. So the designers of Java said, "Hey, we're just going to completely avoid that situation because we will only have single inheritance. Every class, except for one, has exactly one parent. The class that has no parent is called object, right? And that one's kind of the mother of all classes, right? Every class that you write can have trace its ancestry back to the object class. So, for instance, when you write a class that does not have a does not use the extends keyword, the parent of that class is automatically object, right? The object class. All right, and so other languages like Python allow multiple inheritance, right? You can have multiple parent classes out of a single class, but Java avoids that situation. Okay, so that some people, would probably look at that as a limitation because maybe they want to combine the code of two or three different classes through inheritance, right? In Python, that would be allowed, but in Java, it would not be allowed. Okay. Also, keep in mind that that can also cause a lot of problems, right? So in those languages, you can run into some severe problems doing that, whereas in Java, that cannot happen. Okay. So having only single inheritance is makes everything a little bit more safe, but also has decreased flexibility. But there is another construct in Java that does allow for inheritance, okay, and for multiple inheritance, that I should say, and that is through something called interfaces. So we haven't talked about interfaces up to this point. Okay, so here we go. So an interface is a reference type, and it's very similar to a class. Okay, so you can look down here. Here is an example of um, a very basic interface. So you can see I have public, right, and then interface, and then speakable. So in the header, instead of having where you would have class in a normal class, you would have interface. Okay, so that's how you would create an interface. Okay. But there are some extra conditions on the things that you can put inside of an interface, right? In an interface, you can only have constants fields, okay? So the fields have to be constant. And what do I mean by constant? The modifiers are public, static, and final, okay? So this interface has no fields. So let's see if I have, yeah, so here I have one. An interface called grouped interface, and it has a field up at the top. And now you might say, hey, wait a second, you said anything in here had to be public, static, and final. Okay, and that is true. So much so that even if you don't put it in an interface, Java will automatically make it public, static, and final. Okay. All right, so you can only have constants, right? Variables, fields with public, static, and final as the modifier. You can only have abstract methods. So So you can see here's an abstract method right here. Static methods, that's in after starting with Java 8. Default methods also with Java 8 are nested classes. So we are probably not going to talk at all about these different things here, okay? We are going to talk about basic use of interfaces here, okay? So a lot like a class, there's some catches though, right? You can only have fields that are public, static, and final. That prevents the diamond inheritance problem, right? Some of the issues that other languages have with multiple inheritance, okay? And so then you can have abstract methods, and that's what this first example has. It has an abstract method in here, okay? And you can tell that it's abstract, right? Because it's a method, right? You can see those parentheses. It's got a semicolon at the end. There is no method body either. Okay. All right. So here is an inheritance example, another interface example rather. All right, the one that I had here showed you before. So here we can see that we have one field, right? And I already told you I did not mark it public, static, and final, right? But it is by default. As soon as you put that in an interface, Java will automatically make this public, static, and final, even if you do not, all right? And then it's got some abstract methods. This interface has two abstract methods, do something and do something else. Another thing to notice up here, right, is that interfaces, just like classes, can extend other interfaces. So this interface, grouped interface, is a child class of, our child interface, I should say, of interface 1 and of interface 2. You cannot do that with classes, all right? With classes, you can only have one parent. All right. So there are some rules that we need to know concerning interfaces, right? All methods in an interface are public by default. So you do not have to put public modifiers in the header, all right? So that's rule number 1. So over here, you might notice I did not put public in there. I'm going to compile it. Right. And you may be wondering, why do I have this commented out? I have this commented out because I don't have any code for interface 1, interface 2, or interface 3 in the slide I did, just to show you that you can have multiple parent interfaces for an interface. But if I try to compile this, it's going to give me an error, right? Because it can't find interface 1, interface 2, and interface 3. So those are not there. All right, so I'm just going to comment that out, and it should compile after that. Okay, so methods, right, are public by default in an interface. As soon as you put this here, Java will put the public for you. You can put public if you like. That's all fine. No problem. But the minute you try to put something else, like private in an interface, it's going to not like that. Let's see. Although that wasn't quite. Okay, because I didn't put abstract there. That's I wasn't expecting that error message, but yeah, okay. So I had to put abstract on there to trigger this error message. You can see it says illegal combination of modifiers, abstract and private. So in this interface, I cannot have private methods in there. They are by default public. So if I change that to public, it'll be okay. All right. So that's rule number 1. These methods in here are public by default. You can put public in there, but you can't change it to private. All right, rule number 2, all methods except the ones that are marked default or static, which we won't talk about, are abstract by default. So you can omit the abstract modifier in the method header. Okay, so here you can see you can put abstract, right? And it will work, right? Or public abstract, like this, right? So every method really is marked with this public abstract here in a interface. So most of the times people don't put that. You just kind of have to know, okay, even though it doesn't say public and abstract, the fact that it's in an interface and not a default, not marked default or static, then it is a then it is public and abstract. Right? If I try to make another method, in here, like so. So here's a regular method, a method that's not abstract or a concrete method. You'll see you get the error interface abstract methods cannot have a body. All right? So this has to be abstract. You cannot put that method body there. It has to be abstract. Okay? Unless it's default or static. So all fields in an interface are public, static, and final by default, so you could omit those identifiers. So if I go back in here and try to change this to private, you can see I'm going to get an error. It says modifier private not allowed here. All right. So you can put public, static, final if you like. That's perfectly fine. But if you don't put that, for instance, if I don't put final, it's still going to be static automatically. So Java will make any of these fields public, static, and final by default. So you might think, hey, why can't I change that? Because it's not final. But just the fact of it being in the interface makes it final, right? And so final means that you could not change this value afterwards, after it's declared. So most of the time you'll just see it looking like this. Okay. All right, the next rule for interfaces is that like abstract classes, interfaces cannot be instantiated. You cannot create an object right from an interface. And then a big difference between classes and interfaces is that classes have single inheritance. Interfaces can have multiple parent interfaces. All right, so that is a big part of that. Okay, so what you can do, how do you use these interfaces once you create them, right? Interfaces can be implemented by classes using the implements keyword, okay? And I'll show you how to do that in one of the videos that's coming up. Interfaces, right, can be extended by other interfaces. In other words, you can have an interface, right, with a multiple parent interfaces by using the extends keyword, just like we did right here. Or actually, it's better if we look like this. So this grouped interface has parent interfaces, interface 1 and interface 2. So that's similar to how classes work. Okay. So you might notice that that interfaces, even we haven't done the first example of that yet, but they're pretty similar to abstract classes, right? In the sense that abstract classes, they have abstract methods in there, and also interfaces, right? All of the methods besides static and default are abstract by default, right? So they kind of seem the same, right? Um, so so should I use abstract classes or should I use interfaces when I'm talking about inheritance? And that kind of depends. The interfaces are very similar to abstract classes, right? But classes have that single inheritance restriction to keep things safe. But then interfaces, right, because they have multiple inheritance, are more flexible. So you can have a child class that has a parent class, but that implements multiple interfaces. So that allows you to add multiple things into a child class or something that implements this interface. So the question is, how do I know, which one should I use? And the general rule of thumb is that an abstract class should contain the basic common fields and methods that should be shared by all child classes. All right, and then the parent class shouldn't necessarily contain methods that define certain roles or behavior that the object plays or exhibits. So, to me, the easiest kind of example to think about is something like as in a role-playing game. So, say you were writing a some role-playing game, and you had a player class. I'm going to represent these classes as boxes. This in something called UML. So you're making a role player game, and so maybe you have a player class. Inside the player class, you have some fields. These are things that are like common to all players. They have a screen name, and they have some hit points or something like that. And they have experience that they gain by playing the game. All right, so you might have some fields in that class. And then in this role-playing game, then you have classes that each player can assume. So like pirate. So the pirate class would be a child class of the player class, or ninja, right? Or whatever the other classes are, right? Mage or something, I don't know. So all these child classes, pirate, ninja, and mage, they will all inherit, a name, the name field, HP field, hit point field, experience field, right, and so on and so forth in that class. And they will also have some other abilities that they have, like, things that are exclusive to a pirate will go in here, right? So, the sailing skill or something like that, right? What the skill points are at. And here is throwing stars or something like that. And here is spells or something like this. Spell points. All right, so spell points, right, is exclusive to a mage, right, and so on and so forth. And so those would go in these classes here. So you have a pirate class, ninja class, mage class, player class, and they are all child classes of the player class. All right, so these would all be classes over here. So now let's say that you also have some other abilities that are independent of what class your player is, right? So like you have some skills that all players of all classes, like a pirate, ninja, and mage could learn, like Beastmaster or something. They can talk to animals, right? Or control animals. So what you would do, right, or bard or something like that, where they can sing really good and tame monsters. But you want to allow all players to do that. What you could do is have these as interfaces. All right, so you have a Beastmaster interface, you have a bard interface. So all of these would be interfaces over here. All right, and so then you could have a pirate class, right? The pirate class would extend this player class over here, right? So these things, name, hit point, experience, that's common to all players, right? And so what you would probably do is make this player an abstract class. It contains basic common fields and methods shared by all of the child classes. Every player has a name, hit points, experience points, and so on and so forth. So you would make this player class an abstract class. And then this parent class, though, right, if you had a bunch of these different add-on roles that you wanted, say like every player gets to pick 2 of these skills or extra abilities that they could add on, you wouldn't want to have to stuff all that in this class over here. These are more specialized. Not every player is going to choose the Beastmaster skill or the Bard skill or whatever, right? So you would put these in interfaces, and then you would be able to implement those as interfaces. And you can add on multiple ones of these, right? Here, all these classes must have only one parent, so that only makes sense for this to be an abstract class. But these extra abilities, right, can be done as interfaces. So this pirate class or object would implement the Beastmaster skill, and then they could add multiple ones of these add-on skills on here. So that would be difficult to do that with an abstract class because of the single inheritance feature there. Okay. So to me, that's if you played these games before, you probably makes some sense to you. But hopefully that illustrates the difference between an abstract class or interface. Okay. All right. So let's see. What else do we have here? All right, we're going to do the first example next, how we would set these up. It's sort of an artificial example. And then after that, though, we will do another example that's a little bit more concrete, using one of the built-in interfaces that Java has.